Hi, welcome to the session of Finite Automata on Regular Languages in Theory of Computation. Before starting this session, first I'll introduce myself. I'm Dr.M.GEETHA, working as Professor in the Department of Information Technology, S.A. Engineering College. Let us start our session now. Before starting this session, we should have an idea about what is theory of computation, then followed by what is finite automata and regular languages, how far these two are correlated. Let us start with theory of computation. First of all, why do we study this subject in computer science and engineering? One reason is we have to design a mathematical model that should be accepted universally. Then only we can provide the unique solution. So unless otherwise we specified any mathematical model, we cannot give unique solution. That's why based on mathematical concepts, how we are going to design is a concept of theory of computation. So the idea is we are going to design a mathematical model. Using such model, how we are categorizing our real world problems into solvable, unsolvable and partially solvable. So these are all the reasons actually we are studying this topic in computer science and engineering curriculum. Let us move on to the finite automata. Let us start with finite automata. Actually, three basic models given in our syllabus. One is finite automata, followed by pushdown automata. Then finally, in our syllabus, we are having Turing machine. So, I am going to start with finite automata. What is this finite automata as? It is a recognizer. It will accept the input strings and it will decide that whether those input strings are accepted by the automata or not. So it is a recognizer which will accept the input strings and will be getting output in terms of whether those inputs will be accepted or not. But mathematically it can be defined as, see the PPT, here it can be defined as phi tuple of q sigma del q naught f, where q is a set of states. So we are going to design our model in terms of states, and states can be given by the letter capital Q. Then the input symbols, I told you input symbols can be given by sigma, then followed by among those states we have to specify that where it will be started. That can be given by Q naught. Then followed by among those states, more than one states can be final states, that can be given by F. Then the important parameter here what they have given us transition function, that can be defined as del. So based on two parameters actually this transition function will be working. One is among those states where we are standing is a parameter. That time what is our current input? Based on these two the decision will be taking. Then we'll move on to the next slide. So how we are going to represent this finite automata? There are three ways possible. One is transition diagram, another one is transition table, another one is transition function. So I'll give you an example. So see the example. This is what a transition diagram. Using this diagram, how we are going to define our model is, there are three number of states. So among these three number of states, we have to specify that the initial state that can be given by circled arrow. Then followed by among these number of states we have to specify the final state. Final state can be specified by double circled, actually marking of double circle state. Then the transitions I told you that based on two parameters where we are standing, so that can be given by Q1, Q2, Qf, and that time what is our current input symbol. Based on these two parameters the decision will be taking. Here decision whether it has to move on to the next state or staying on the same state. This staying on the same state can be given by self loop. Moving on to the next state, that can be transition from Q1 to Q1. In that way we have to define our transition diagram. This is one way of representing our finite automata. Another way is transition table. This is also the equivalent to transition diagram. There are three states. So three states can be given in the row side. So among these three states, we have to specify the initial state and also the final state. Initial can be given by simply arrow. The final state can be either circle or star, we can specify here. Then the transitions, in the column side we have two symbols. In this diagram consists of only two symbols. So two symbols can be given in the column side. So at Q1, where we are standing at Q1, what is our current input symbol? 0. At that time, we are moving on to the next state. So Q1 to Q2 based on the input symbol 1. Transition to be to the state Q2. In this way, we have to specify our transition table and third one transition function. Simply, I told you that del is a transition function. Then we have to specify where we are standing. So where we are standing is Q1. Then at that time, what is our current input symbol? Current input symbol is suppose 0. That time where we are moving is we are maintaining the same state. In this way, the transition function actually we can define it here. So either transition diagram or transition table or transition function, either one of the representations, we can specify here for representing our finite automata. So in this way, we can actually design a finite automata. Then the next definition I have given in the title is regular expression. So what is regular expression is, actually now we want to correlate the concept of set theory into the regular expressions. In the set theory, a bag consists of one element. Suppose empty bag or null set. How these three elements, that can be defined in regular expression is, see the basic symbols. These three are basic symbols. These three are basic symbols. Okay, just a minute. Actually, every letter of the alphabet, which means that bag consists of one element. How we are representing in the regular languages, simply a letter, what we are using in the bag, that can be defined here. Then null string is another concept, followed by empty set. These three are actually basic elements. These three are basic elements of regular expressions. So among these elements, we can apply these three operations. One is concatenation, another one is actually union, then followed by clean closure operation. So what is regular expression is, now I am actually telling that how these elements, elements of regular expressions are related to set theory. So that I started with a bag consists of one element and empty bag and actually null bag. Actually the element, which is simply specified as same letter, and null string is represented with these 5 and empty set is represented with epsilon. So among these three are basic elements. Among these three basic elements, how we are going to use our operations, suppose regular expression R1 is one regular expression, R2 is another regular expression. So concatenation, we have to see the first expression first, then followed by the second expression. So that the operation, concatenation will be R1 dot R2. Dot is actually, we need not to mention dot always, without implicitly, which means that R1 R2 means R1 dot R2. Then followed by the next operation union R1. The symbol plus is used. Actually the plus is indicating that here or R1 or the union operation R1 or R2, which means that either R1 or R2. Followed by the third operation R1 closure, which means that R1 closure, actually this operation we can apply into the one set. The meaning of the closure is 0 or more number of times repetition of the same elements in the R1. So these are all the operations actually we are going to see in regular expression. So our next topic is how far the finite automata and this regular expression are correlated. Yeah, I have given an example. This is the example for regular expression, and the meaning of finite automata. Here I am using deterministic finite automata. Meaning of this regular expression is, first it has to see that either 0 or 1, then followed by, I told you that between the operator, between these two expressions, the operator dot is there, then followed by 0 or 0 plus 1 whole closure, then followed by 0 plus 1. Here the meaning is it has to accept either 0 or 1 as a first symbol, then followed by any number of either 0 or 1, then followed by only 1, 0 or 1. So this is the meaning of this regular expression. For drawing this finite automata, suppose I want to mention that it has to accept 0 or 1. 0 plus 1 or 1, anything can be given here. So this is the finite automata from one state to another state, how it will be accepting either 0 or 1. This way we can relate our regular expression into the finite automata. This is one gate question. They are asking about how the number of states in the minimum sized DFA that accepts the language defined by the regular expression. For this, they are asking about, for this expression, how many number of minimum sized DFA and how many number of states are required. So see the expression 0 plus 1. So for this I have given about two number of states are actually required for representing either 0 or 1, then followed by 0 plus 1 whole closure. Then whole closure means either 0 number of times it will repeat or more than 0 number of times it will repeat, then followed by 0 plus 1. So this is the meaning of finite automata, but they are asking about minimum sized DFA. Here the minimum size means actually we will be starting with 0 plus 1, either 0 plus 1, then followed by 0 plus 1 whole closure, then again followed by either 0 or 1, either 0 or 1, then either 0 or 1, then we can specify this as final state. So for this case, 0 plus 1, then 0 plus 1 whole closure, then followed by 0 plus 1, we can able to accept the given string, 0 plus 1 followed by 0 plus 1 whole closure, then followed by 0 plus 1. So minimum number of states required for representing this regular expression is 2. That's why D is the answer. So in this way we want to find out that for the given regular expression, what is the diagram will come. Then from the diagram, what is the question we want to see here. From the diagram, they will be asking minimum sized DFA. So that for minimized DFA, how we will be getting is, I have given you. Then here I am using only 2 states. So the answer is 2 states. Let us move on to the next question. See the question. Given the language L, they have given some strings. Which of the following strings are in the L closure? So we want to find out the machine first, and from the machine what are all the possibilities of inputs that will be accepted by the machine. Here they have given. We want to find out the answer. So see the combination AB combination, then followed by AA, then followed by BAA. Whole closure we want to find out now. So already I told you that closure means 0 or more number of repetitions of these 3 strings. Then go and see the first input ABB. So AB is available here. So string AB is available, then followed by A is available, so that AA is available, then BAA is available, Then the repetition of again one more time A, B here coming, so that A, B accepted by the language, then followed by AA. So in this way you want to find out that all the strings are here, the meaning is any number of times the given strings can be repeated. So we want to split our input into according to the inputs what they have given in the L closure. So in this way we want to find out the strings are present in the question or not. Here all the strings are what they have given based on the conditions what they have given present, so that the input string A is accepted by the language of L closure. Then followed by the second one. So we will start with AA. So AA is possible. Then again AA, that is also possible. Then BAA, this is possible. Followed by AA. So second is also possible. Then we will move on to the D1. C is also possible. Then consider this D now. BA. So BAA is possible. Then followed by double A is possible, so that which is selected, then followed by AB is possible, okay, then followed by double A. So this is also possible. So D is accepted by the given language. See the last one, the string C. Here BAA is possible, then followed by AA is possible, followed by AB is possible, then followed by double A is possible. Then consider again double A is possible. What about this B? Definitely we cannot accept the last B, which is not in the language, so that the string C will not be accepted by the given question L closure. So in this way we want to find out that the strings that will be accepted by the finite automata or not. Let us move on to the next problem. See the problem. If L is a regular language and over sigma equal to A comma B they have given, which one of the following languages is not regular? So here one concept we want to see here. The thing is, if you can able to draw the machine means the given language is regular. Machine in the sense, if you can able to draw the finite automata means the given language is regular, or otherwise the language is not regular. See the first condition. So they have given. Condition for y. Y belongs to sigma closure. They have not given any condition for x, but the suffix y they have given, so that this is regular. Because only thing is they have given condition for y. So see the controversy. Here they have given the condition for x. X belongs to sigma closure and there exists y. Among themselves there exists y. So which will be coming under the concept of prefix of L. So that which is regular. So condition for x they have given, condition for x and y they have given, so that based on the condition we can able to draw the diagram. And the last one L followed by L reverse. So see the condition L reverse. So both they have given. First we have to draw the machine for L, then we have to followed by concatenation, then followed by we have to draw the machine for L reverse. So both are possible, independently both are possible, so that L dot L reverse is regular. But coming to the part of B, W reverse. So here we have to see that how these two at a time is possible here. Definitely we don't have any algorithm for finding the word and its reverse, so that W reverse is not regular. So the answer is B, because they have asked about which of the languages are not regular. So W and its reverse is actually not regular. Let us move on to the next question. So see the question. They have given one language and another language. See the language A to the power 2 plus 3k. See the second language B to the power 10 plus 12k. They are asking about which one of the following can be a pumping length actually for language L. So for representing either X or Y they have asked. Either X or Y they have asked. For representing A, we need minimum 2 A's. For representing B, we need minimum 10 B's. So see the outputs, A is 9, B is 5, D is 3. But for representing B, we require minimum 10 B's. So that 24 is answer for this question. So in this way, we want to actually find out the solution for either A or B representations. Let us move on to the next question. Which one of the following regular expressions represents the language? Language they have given set of all binary strings. See the question. Set of all binary strings having 2 consecutive zeros and ones. 2 consecutive zeros and 2 consecutive ones. So we want to find out the solution, how we will be able to producing 2 consecutive zeros and 2 consecutive ones. So for this case, answer is B. First I will explain the answer. 2 consecutive zeros we need, 2 consecutive ones we need. So how we will be getting 2 consecutive zeros? For this case, 2 consecutive zeros they have given and 2 consecutive ones they have given. So in between zeros and ones, they have not mentioned any kind of condition here. So in between these two strings, anything can be coming, So anything can be given by 0 plus 1 whole closure. So this is one possibility. Continuous zeros, continuous 1. In between these two, what will be coming is a concept. So anything can be coming. So anything can be coming will be given by 0 plus 1 whole closure. Then you want to consider that before this string what will come. There also anything can be coming. So 0 plus 1 closure. So this is one part. So another part, same thing. Continuous 2 zeros and continuous 2 ones. Either zeros can be coming first or ones can be coming first. Suppose ones, consider ones are first. So 1 1 followed by anything can be coming, then followed by 0 0. Then initially we started with 0 plus 1 whole closure. Here the second part 0 plus 1 whole closure will be coming at the last. So in this way either zeros or ones, continuous 2 zeros and ones or continuous 2 ones followed by 2 zeros can be written as like using B expression. So this is the meaning of this question, but we can verify that how the other options will be coming here. Here they will be giving 0 0 1 1. So the meaning is they have given all binary, but they have mentioned that 0 0 first, 1 1 next. Then here 1 1 first, then 0 0 next. So here they have actually considered is that continuous 0 0 1 1, then 1 1 0 0. They have not covered all the combination of zeros and 2 zeros and 2 ones. So it should not be an answer. Then the same way the reverse version they have given in D and C. So these two will not be an answer because of the answer all. We want to choose only answer B. So in this way we want to select that how others will be omitted because others are also correct here. So the meaning is it has to accept 2 zeros and 2 ones, but the condition is all binary strings. Using B only we can able to find out all the binary strings. Other strings, some restricted kind of 2 zeros and 2 ones will be able to find out here. So let us move on to the next question. Yeah, which of the following regular expressions represents the set of all binary strings? Condition is an odd number of ones. So first I would like to tell you about how the odd number of ones will be coming. So this is the condition, closure, double one closure will produce even number of ones, followed by this one, you will be getting odd number of ones, or otherwise 1, then double one closure is actually a concept of how the odd number of ones we will be getting. But they have mentioned that in between odd number of ones, okay, but whether they are continuous or not, they have not mentioned. So in between the number of ones, any number of zeros can be coming. Otherwise, this one, maybe at first or at last it will be coming. So that we want to find out that how the odd number of ones will be getting. So see the A option, 2 ones are there. So in between these 2 ones, at any place zeros can be coming. So 0 closure 1, 0 closure 1, then 0 closure, then whole closure, then this whole closure will produce the even number of ones, then followed by 1, here 1 will be at the first question. So 1, in between that one and the followed by part, we have 0 closure. So this is okay. Using the string, I can able to produce odd number of ones. So the controversy is started with 1 0 closure. Here ended with 1 0 closure. So this is also possible. Then coming to the part of next one, the double 1 is there, double 1. Then in between 0 closures are there. Then 0 closure 1. So among themselves interchanging. So this is also possible. So all the 3 cases we can able to produce double 1, whole closure 1. So that it is a combination of odd number of ones. Then see the B part, B option. Here using this how either 0 or 1 closure. Either 0 or 1 closure. Actually this is the concept of any number of ones are possible, any number of zeros are possible, any number of zeros and ones are possible. Followed by 1 we have given. So the meaning is, suppose 2 ones will be coming here, followed by 1 1. So that using this part, we can able to produce odd number of ones. Using this part, odd number of ones. So odd number of ones plus odd number of ones. Sometimes even number of ones are also possible here. So we should not use the B option. So that the answer is A, C and D. Let us move on to the next question. Which one of the following is true? So see the question. L equal to A power n, B power n is regular, they have given. The next one, the prime A power n, n is prime is regular. Then followed by W, then W. They have given 3k plus 1 for some k. They have given is regular. Then the language L, W, W belongs to sigma closure is also regular. So we want to all the regular languages that they have given. We want to find out which one is regular. Here we have one theorem which is available, pumping lemma for regular languages. Using pumping lemma, we can able to find out the given language, whether which is regular or not. For this A power n, B power n, this is not a regular language. This is context free language. And also the A power n, n is prime is also context free language. Then followed by this is also context free language. The reason is, suppose we want to among the input strings, you want to divide which is into x, y, z, and we can pump the y number of characters here. Suppose I can consider for y, only the letter A. Suppose one time we are pumping, A will be maintained as A. So the property of A power n, B power n will not be affected. Suppose 2 times I am pumping the character A. What will be getting? 2 number of A's we will be getting. But the number of B's, same number of B's only we will be getting. So that time the property, A power n plus 1 you will be getting, B power n you will be getting. So the property of number of A's are equal to B's will be actually affected. So that which is not regular. Using pumping lemma, we can able to prove that y The given string is not actually regular or not regular. So based on that, these three are context free languages. Only thing is W. So the meaning is we can able to design a finite automata which will accept the strings which have been given in W and also followed by the same W we can accept. So in this way, using pumping lemma, we can see that whether the given language is regular or not. So see the another question. Which one of the following regular expressions correctly represents the language of the finite automata given below? So the automata they have given, strings again they have given. So one by one we want to verify that how the strings will be accepted by the machine or not. So A, B closure, so A is that, okay, see the, so at a time it will accept only one character. Start with A, so A is available, okay. Then B closure is available, followed by B, this B is available. Then A, so again it will take the same path, then followed by B closure, again B closure, R. So now we are actually standing at the final state. Or we have to follow that BA closure. Suppose how will be, now we are standing at final, but for the second input we have to start from the initial state. Here we have to start. So using this diagram we cannot reach the initial state. So this will not be possible for actually this string is not possible. Using this diagram we cannot able to find out the string. See the correct answer. This is the correct answer. The thing is BA closure. So start with B. A closure is there. Then followed by A, this A. Then A, B closure. This one A, B closure. Followed by B. This is also possible. Now we are standing here. So after completing this part, we are standing here. The second half is possible here. For the case of first option, after completing this one, we are standing at final state. But after completing this one, we are standing at the initial state. That's why the second half is possible. That's why here the second half is not possible. So in this way, we want to find out the strings will be accepted or not. We want to find out here. Then move on to the next question. The last part, consider the diagram. Same strings they have given, and straight away we will move on to the answer. So easily I can explain you. See, the answer is C. 1 is that, okay. The first part is 1. So this is 1 is available, then followed by 0 closure, then followed by 1, then again 1. So 1, 0 closure, 1, okay. So after completing this, we want to, this is a final state, so we want to make the operation either or, so that 1 followed by 0 closure or 1 whole closure is answer. So if see the diagram, 1 0 closure, then followed by plus 1 then whole closure will be the answer. Suppose actually this is an answer. See the first one, they have given continuously 1 followed by 0 closure, then followed by 1 whole closure. 1 0 closure, then dot operator, 1 whole closure. So see the diagram. If you are standing at the final state, we should have the operator union, but they have given here concatenation. So the reason we have not chosen the first one, that's why we have chosen the C option. So in this way we want to find out how the strings will be accepted by the finite automata. So see the question. Here they have given that W is a string, ends with the substring 0, 1, 1. So here also D is the answer. So straight away I will move on to the D, because 0 followed by 1, this one, this one. So in a straight way we have to give the substring 0, 1, 1 in the diagram. So in between what are all the strings are possible, we want to verify. So before starting this 0, one closure is possible. So one closure they have given. Then after this 0, 0 closure is possible. So another option, because for getting 1 it has to move from this state to another state, so that 0 closure is possible. And after coming to the third state, for getting 1 it has to move on to the final state. Suppose 1 comes, where it has to go. So we have to specify. So if 1 comes, it has to move on to the final state. Suppose 0 comes, it has to go to the previous state. So this is correct. Then the same way you are standing at the last state. If 0 comes, where we have to mention. Okay, 0 comes, we want to move on to this state. Suppose 1 comes, we want to move on to this state. So all the possible ways of verifying that if 0 comes, where we have to go. If 1 comes, where we have to go. In this way, we have to verify that all the combinations whether they have given or not for getting 0, 1, 1 as substring. For the diagram D, we have verified that all the combinations they have given. So our option is D is correct. So I think I have completed all the questions. So far we have covered what is finite automata, then followed by regular languages, how for these two are correlated. The questions actually related to how you will be getting from the regular expression to automata, as well as from automata to how you will be getting the regular expressions, how the regular expressions will be accepted by the machine we have seen. Thank you so much.